Hello, my name's Jeff Messier. I'm a professor in electrical and software engineering in the Schulich School of Engineering. And this is a presentation that I'm going to be delivering at the 2025 Canadian Alliance to End Homelessness Conference. And the title is, Can Chat-GPT's style AI help us understand emergency shelter data? And so before getting into it, I want to acknowledge that currently I'm living and working in Treaty 7 territory, which includes the Blackfoot Confederacy people, the Siksika, the Piikani, the Kainai First Nations, the Tsuut'ina First Nation, the Stoney Nakoda people, including the Chiniki, Bears Paw, and Goodstoney First Nation, as well as the Métis Nation of Alberta, Districts 5 and 6. I was born in Western Canada. I was born in Treaty 4 territory, near the ancestral lands of the Nikanit Band. And I've always lived in Western Canada, and I'm very grateful to be here. And you know, I think it's hard for a settler like me to really truly acknowledge the land, and so I always put up the QR code for the National Center for Truth and Reconciliation, and I think it's really important to visit that site and others to get the perspectives of the people who truly can call this their ancestral lands. I also want to start off by gratefully acknowledging the organizations that have supported us doing this work. So, chief among them are the Calgary Drop-In Center, first of all. As you'll see, the Drop-In Center was very much a partner in this project. We've also grateful to receive the acknowledgement and support from the Alberta government, and also the financial support from Making the Shift. So, AI is a big topic, and before we get started, I'm going to spend a little bit of time sort of putting everything into kind of context and talking about a bit of terminology, because we've gone from AI being sort of a niche research area maybe 10 years ago to something that everybody uses in their daily lives. And the AI that we're going to be working with, or that I'm going to be talking about in this presentation, is very related to Chat-GPT, but it's not Chat-GPT. And so I want to just sort of lay a bit of groundwork to better understand that. So first of all, what is AI? I think people have sort of a general idea of what it is. Obviously, most people know that it's a computer program. It seems intelligent. But very specifically, AI is a computer program that implements a mathematical model. So that's sort of where the magic of AI happens. And these models are good at some things. They're very good at recognizing patterns. So for example, AI is used commonly for facial recognition. They're also good, it turns out, at generating patterns. And this is kind of where Chat-GPT excels. So Chat-GPT is a language generating program. So if you give it a prompt, it generates language that is relevant to your prompt. So now, how do people use AI? So most people that are familiar with using AI use it essentially in conversation. So you use a Chat-GPT style chatbot where you have a prompt and you ask some questions and you get some information, and then you can maybe put in some follow-up prompts to help kind of refine that information. The other way that AI can be used is integrated kind of in the background of a computer system. And this is the way that I'm going to be talking about it being used today. So I'm not going to be talking about how to better sort of enter prompts into sort of a chatbot style AI. I'm going to talk about how it's possible to use AI kind of integrated into the background in a computer system to do some work for us. So what do people use AI for? Again, Probably the most common application of AI today is getting information or advice. So you fire up Chat-GPT and you say, hey, Chat, where should I go for dinner tonight? Or I'm planning on visiting Montreal and I've never been there. What are some fun things to do? And then you get information back. So it's kind of, in many ways, the evolution of the web search. AI can be used for companionship and entertainment. This is maybe a little less common, but people are befriending their chatbots. They're interacting with chatbots for fun. But the third way that you can use AI is to help make decisions and to help kind of understand data sets. And this is how we're going to be using AI in the project I'm going to be talking about. So if that's some perspective on like what AI is in generally, now let's sort of specifically talk about Chat-GPT. So what is Chat-GPT? So Chat-GPT is a type of artificial intelligence. There's many other types of artificial intelligence. Chat-GPT is only one of those types. And specifically, Chat-GPT is what's known as a large language model, or LLM. So like all AI, it's a mathematical model, and its mathematical model happens to be just really big. So it has, and by big, we mean that it has a lot of parameters. Its mathematical model has a lot of numbers that it uses to understand and generate language. And it's a language model because ChatGPT very specifically is designed to understand and generate language. And of course, there are many different types of LLMs. Most people will be familiar with these, again, just from your sort of online AI user experience. Maybe some of you use Gemini, DeepSeek models, Claude, GPT-4, GPT-5. And it's important to understand that each of these different types of AI implement a slightly different mathematical model for language. So they all behave kind of similarly, but they have a different number of parameters. They're different sizes, we would say, and their parameter values, the values of their parameters within their mathematical models will be different. Now, another question that we can ask is, where is ChatGPT? So we obviously interact with AI on our phones, on our laptops, but that's not where the AI calculations are actually performed. So when you interact with ChatGPT, those calculations used by the AI model are done in the cloud. And what we mean by cloud, of course, is a cluster of servers in the data centers operated by the artificial intelligence companies. So OpenAI, for example, has a whole bunch of data centers consisting of a whole bunch of servers around the world, really. And when you interact with ChatGPT, your prompts are sent over the internet to one of these servers. The server sort of crunches away on them and then generates the response back to you. So, and of course, the AI company that you're using owns these servers. It's their property. And less commonly, but kind of important for what we're going to be talking about, is that it's also possible to run AI locally on your own system. And there's a couple of ways to do this. One, for more the kind of the nerdier crowd, is a website called Hugging Face. And Hugging Face is where you can download a huge number of different artificial intelligence, different types of AI models, including the DeepSeek and ChatGPT models, to run locally on your computer. But if you're using Hugging Face, there's typically coding involved. There's also something called LM Studio, which also allows you to run AI locally on your computer, but using the more familiar kind of prompt interface that people are comfortable with. And LM Studio is relatively recent, but it's actually kind of it's a cool tool, and if you haven't tried it, it's worthwhile downloading it and checking it out. The reason why it's important to understand where ChatGPT is, it primarily comes up when you're thinking about managing someone else's data. So when we're using our own data, we enter our own information into our prompts, as part of our own free will. But if you're working at an agency and you're working with data that contains information, the information of another person, you have to start thinking about things like confidentiality and privacy. And central to that is this notion that, AI is free. And of course, we all use AI tools, again, Chat-GPT being chief among them, for free. We just open up the OpenAI website and we can interact and have all of this benefit, I guess. But it's important to understand that the free versions of AI will make use of your data. And this is, again, probably not a surprise to most people, but if you look at OpenAI's information policy, for example, and the other ones are similar, it classifies user content. It says that it will collect personal information, and it classifies personal information or its definition of personal information includes the information that you type into your prompts. And so that's basically how you essentially pay for the free AI service, right? Like you're typing your information in there, and they make use of your information, and then they monetize it, with marketing or whatever else they're doing. So that's obviously your personal choice if you're using it with your own information, but if you're using it with data that contains information for other people, privacy is an important concern. And most artificial intelligence companies will provide you with an AI that keeps the information processed by that AI private if you are a paying customer. And so again, it's still important to understand that if you're paying an AI company to keep information confidential, the AI still runs on servers owned by that company. So it's still not local to your own computer. It's just the company promises not to make use of the information or let anybody else see it. And it's kind of similar to, if you work at an organization with, Microsoft-based email, for example, most of that email runs on Microsoft servers, not on your company's servers. And then it's just, your company pays to keep that information private. So how does all of this relate to homelessness? Well, you'll remember the way that we're going to explore using AI is as an assist or as a tool for helping us make decisions. Now, kind of broadly speaking, if you think about decision making in the housing and homelessness system of care, you can kind of think of your decisions as very crudely and broadly being defined into two categories. There's decisions made for an individual. So if you happen to be interacting with, maybe you're a caseworker, you're interacting with an individual person, that person has, some goals that they want to achieve, and you're connecting them with supports. The second type of decision is decisions for a large group or program. And so this is where maybe you're, let's say, a manager of a shelter or a housing program, and you're interested in either introducing a new program or evaluating some of the programs you've got currently in place. And you want to understand things that, not necessarily that individual level, but sort of a bigger level. And so how can AI help in these two situations? Well, let's talk about artificial intelligence for making decisions at an individual level. And this is sometimes things that I'm sort of asked about this from time to time. Could AI do a better job when connecting an individual person to support services? So in a way, be kind of like an automated case manager. In my opinion, I think the answer to this question is no. I don't think AI should be making decisions for people at an individual level. And there's a couple of reasons for this. The first one is that, AI algorithms aren't perfect. So the algorithms themselves, the mathematical models inside the artificial intelligence programs, don't make perfect decisions every time. Now, you can improve this by training the mathematical models, modifying them using data that's specific to your application, but this is a lot of work and it needs to be carefully tested. But let's even assume that this problem is solvable. The second bigger problem is that our data isn't perfect. So AI only understands, the only information it gets to work on is what you've got written down in your data set about a particular person. And in order for that AI model to make a good decision about connecting people to supports, you would have to have perfectly represented in your data set all of the main things that could affect somebody's successful transition to housing, for example. And anybody who's worked with data, particular data, kind of on the front lines, will know that, our data is far from perfect, right? Like we don't necessarily aren't able to fill out all of the fields, or, we're not necessarily able to get someone's full picture because they're not able or willing at that point to share it. And so our data, the image of a person in our data does not often represent who that person really is and what are the factors really going on in that person's life that will affect their, again, let's say their successful transition to housing. So I think it's very risky, and I personally wouldn't advise trying to make AI based decisions on an individual level. This might change in the coming years, but where the technology is right now, I'd be very reluctant to do that. However, I do think that there's a lot more promise into using AI to understand larger groups, sort of that evaluation of bigger programs and bigger groups, sort of the second type of decision making we talked about. And that's what we're going to be focusing on in this talk. So to understand how AI can help us understand larger groups, it's important to talk about the nature of data in the housing and homelessness system of care. So often, the data that we collect is in the form of free text kind of case notes that get saved in databases. And these case notes are great when understanding an individual. So if you're an individual caseworker and you want to understand the person sitting across from you, you can pull up their case notes, and in a minute you can read them and understand that person's context. However, if you're trying to design new programming or evaluate existing programming, you need to not just understand what's going on at that one-on-one level. You need to understand what's happening with large groups of people that are going through your agency or your service. And case notes are not great when trying to understand what's going on with large groups of people. So for example, the drop-in center in a year records about 60,000 case notes, and if everyone takes a minute, each one of them takes a minute to read, then you're looking at 42 days for a human to read all of those case notes. And so right now, for things like program design, how would we answer a question like, what percentage of people in our shelter are looking for employment, for example, if you're thinking about setting up an employment program or advocating for funds. So we would resort to surveys, right? So you would survey the people using your program or your services, and surveys are an effective way to record data, and they kind of make the world go round, right? Right now. But of course, they are more work for staff, and depending on the question, they can be potentially re-traumatizing. So wouldn't it be great if we didn't have to do surveys at all? Well, one way to reduce, maybe eliminate, that's very aspirational, but eliminate surveys would be if we can extract the information that we need from the data that we already have. And if the data that we have is in case notes form, then we would just have to get really fast at reading a whole bunch of case notes data. And this is exactly where AI can help us. So large language models are designed to process large amounts of language really, really fast. And we can leverage this to pull information out of case notes data. So then basically we have three goals for our project. The first one is to use a large language model AI to determine whether or not certain themes, things like seeking employment, show up in 60,000 case notes that were case notes and logs that were collected at the Calgary Drop-In Center. So this is not Chat-GPT that we're using, but it is another large language model that we run locally on our own computers, not on the servers of an AI company. Our second goal is to check our mistakes. So AI makes mistakes. Never ever think, and I think people know this if you've used AI absolutely makes mistakes. And so we need to check our work, basically. And so we're going to be checking whether or not the themes identified by AI for our project, how they stack up when we compare them with humans who are doing the coding. And then the third goal is to kind of explore ways, once we have these themes from this large amount of data, how can we present these in a way that's like meaningful and relevant for human decision makers? So the data that we are working with for this project is very, very sensitive data. So these are case notes and logs collected by the Calgary Drop-In Center as part of the services they provide. Names have been redacted from the data using sort of an automatic script that just searches for names and replaces it with the word name. But obviously these notes are still very identifying. So it's important that we treat this data very carefully and keep it very secure. And so we talked to a lot of different partners when setting up this data project. So we have authorization and approval, first of all, from the Alberta Ministry of Assisted Living and Social Services. We also consulted and got approval from the Alberta Office of the Privacy Commissioner to do this work. Of course, the University of Calgary Ethics Board was necessary to apply to them and get approval from the ethics board. And finally, last but not least, of course, the Calgary Drop-In Center, which was one of our major projects as well. So there was actually quite an extended period of consultation around this project before it got off the ground. But once it did get off the ground, the Calgary Drop-In Center provided us with 60,000 redacted case notes. Now, this type of sensitive data can't just be uploaded to Chat-GPT servers, right? And so the data was contained entirely inside the University of Calgary secure computing facilities. And importantly, the AI that we use ran locally on university computers and servers and did not in any way involve any sort of cloud services. And so when we had the notes inside our secure computing environment, we basically used them two different ways. The first way is that we took 400 randomly selected notes and 3 people, me, Madhu, and Teal, coded them for themes. So we read the notes, we performed thematic analysis on them, and this was in order to check that the AI was behaving properly. So the AI was checked against these 400 notes to see how it was performing. However, the purpose of the AI, of course, is to read more notes than is practical for a human. So the AI, and this is the name of the AI model, was DBERT A version 3 base task source NLI. So this is not Chat-GPT. That's the name of the LLM that we used. This is an LLM that's particularly good at thematic analysis and was also small enough to run locally on university computers. This AI analyzed not only the 400 notes that we had checked, but then after that, the full 60,000 notes. Now, before we sort of critically examine the performance of the AI, it's important to remember that humans are not perfect either. AI is not perfect, and humans are also definitely not perfect. And so when Madhu, Teal, and I were analyzing our 400 case notes, we actually kind of had a hard time. Like, we had to iterate 3 or 4 different times. We created an annotation guide to sort of guide how we would classify our different themes. And even then, we couldn't agree. It's not like there was conflict in the team or anything like that. We just it's really hard to determine whether or not certain themes are present in a particular case note. And so what I'm showing here is basically my report card versus Madhu and Teal. So for each note, I took the themes that Madhu and Teal had agreed upon, and then I checked to see if I also identified one of those themes. If I did, I got a check mark. That was correct. And if I missed a theme, that was considered a mistake. And so I don't want to throw too many numbers around in this presentation, but it is important to have at least a few numbers. And so my report card consisted of two numbers, basically, precision and recall. And precision is the percentage of the themes that I chose that were actually correct, right? So if I chose 10 themes, what percentage of them did Madhu and Teal also choose? And what percentage of them did I choose that they didn't? So that's precision. So, and then the other one is recall. So what percentage of the correct themes did I actually correctly identify? Now, you'll see here that my precision was 62% and my recall was 73%. So what does that mean? So recall of 73% means that I got 73% of the themes that Madhu and Teal also identified. That means I missed 26% of them, basically. So 26% of the themes that Madhu and Teal thought were important, I just completely missed. What about my precision? My precision was 62%. So of the themes that I did identify, I only got 60% of them right. 40% of the themes were ones that Madhu and Teal hadn't even identified for the particular notes that I looked at. So 40% of my themes were incorrect. And so what did I do well on? What did I have trouble on? So I did great on the overdose theme because you're basically looking for keywords there, right? You're looking for the word overdose or naloxone. And so it's very easy to see if the theme of overdose occurs in a particular case notes. I did well on the theme interacting with EMS, emergency medical services, again, because you're kind of looking again for keywords like ambulance, EMS, paramedic. I did pretty well on actively working to find housing. But what did I do badly on? My worst theme was, an indication of emotional distress. That's a very subjective theme. And, there was times where, and so my precision was super low, which means I flagged a lot of notes as indicating emotional distress that Madhu and Teal did not think contained emotional distress. So it's important to know that this thematic analysis works, we're trying to get AI to do it, but it's actually pretty hard even for a human. And so rather than expecting AI to be 100% right, we're hoping that it gets at least, kind of close to what we would expect from a human. So as it turns out, the AI is worse. The precision, I was getting about 60%. AI got precision of about 43%. That means about half of the themes that it identifies were not themes that we identified as humans. The recall was 63%. Not bad. My recall was 70%, but that still means that the AI is missing about 40% of the themes that the humans thought were important. If we look at what the AI did well on and what the AI struggled with, kind of the same thing as humans. So the best theme for the AI was overdose or use of naloxone. Not 100% like I was able to get, but in the high 80s, mid to high, or in the sort of mid 80s, I guess. EMS interaction was, one that it did better on. Physical violence as well. The themes that it had trouble with, kind of like the humans, were these kind of squishier ones where, things like positive relationships or harmful behavior but not violent behavior. So that's something that, we struggled with as humans and the AI struggles with as well. And so these numbers, not to sort of dive too much into the details of the numbers, but if we kind of step back and say, okay, how is the AI doing? I would say it's not quite there yet. It's enough that we can generate some interesting results, and I'll show you those in a second. But I think there needs to be more work here before we can say that this is ready for large scale deployment, right? I would like to see that precision up to around the 60% range. I would like to see the recall up to, somewhere in the 70% range. Can we get it at least close to, the fallibility level of a human? But if we take a look at some of the themes that the AI and the humans were good at, we can still kind of see the potential of this technology. We can see how it could be applied. So this slide shows a heat map that shows us the entire year of case notes that we worked with, analyzed for the theme of overdose or use of naloxone. So now let me explain this heat map. So we have 12 months, so we have 60,000 case notes collected over 12 months. And so the month number is on the y-axis here. And then on the x-axis, we've got the day of the month. So basically the first row is, let me see if I can. So the first row here is basically the first month of data, right? So the first square is the first day of the first month. Here we have the 5th day of the first month, and here we have the last day of the first month. This is the first day of the second month. This is the first day of the last month. So what do each of these squares show us? Basically, each of these squares, the color of each square indicates how many times the theme of overdose or use of naloxone showed up in case notes on that day. And so the darkest color is, didn't show up at all. And then the lightest color, yellow, is it showed up as 5 or more times. And if we look at this heat map, it gives us an idea of how often basically staff people are dealing with overdose in a facility. And, it's not every day, but it's kind of most days, at least one, if not, multiple times, and particularly a few days where you get the full yellow, right? Like quite a few mentions of overdose. Now, how would you use this as a program, a designer or manager of the shelter? You would look at this map and say, basically every day, my staff are dealing with some, one or more overdose events. And so, the Calgary Drop-In Center does this already, but, this would be a clear sign that you have to be, really up to date on, overdose training for basically all of your staff. And, this couldn't be something that you would just sort of like, when you're onboarding somebody brand new, they get their overdose training, kind of within the first month, because they'll definitely see an overdose probably in the first couple days when they're there. And so this is the kind of thing you can look at this heat map and you can say, okay, thinking very broadly about the programming and the training that I have at my facility, does it sort of agree with what I'm seeing? The second map is one that's a little bit more hopeful, and we generated the same map with working on finding housing, the theme working on finding housing. And here we see that basically every day in the notes, we've got 5 or more mentions of somebody working on finding housing. And this is, hopeful, right? There's a lot of people, a lot of conversations about finding housing and, taking that first step out of experiencing homelessness. So this is a good news picture. And again, from a leadership management point of view, with this much mention of housing, it's probably because you've got a bunch of housing programs in your facility, and I know the Calgary Drop-In Center does. And so this would be a picture where you could look at it and say, yeah, this is great. We've got a lot of conversations around housing. We see it a lot in our data. And maybe now you want to get a little bit more granular, right? Like maybe you want to start looking at things as like, okay, well, what kind of housing are they looking for? And is this, is it family housing? Is it singles housing? Is it, what are the needs of the people? Do they have accessibility issues maybe when they're looking for the housing? So you see lots of activity here, and it's kind of a signal to sort of, double down on this a bit and, diving into this data in a little bit more detail. And that's it. So, conclusions at this point, I think AI, in particular large language models, have real potential in providing insight into large amounts of case notes data. And this is kind of an application that I'm really excited about because case notes data is pretty fundamental to housing and homelessness. Not only does it, it's kind of the mode of data collection that exists today, but it also allows people to tell their stories in their own words, right? And you wouldn't have to sort of go too much further to imagine a case where maybe it's not just the caseworker just writing down things anymore. Maybe it's the person writing their own story. Maybe it's an audio file of the person just talking about what they've experienced that is then transcribed using AI into text data and then analyzed afterwards, right? So you can have somebody who's not endlessly filling out surveys and forms. They just sit down and they just sort of talk about what they've experienced, and then the system adapts to extract the information that it needs from the data that is left in the form that is most comfortable for the person receiving services. And so I'm excited about the potential of using AI to extract meaning from the data that we've already got. Instead of needing to always do a survey every single time we want one of these questions answered. And, it's not going to probably completely eliminate surveys, but even a reduction in the amount of surveys that we collect, I think is, potentially valuable. And where the technology is at right now, like the level of AI that we're using for this problem does require IT technical expertise to implement, right? So you still have to be working with, an IT professional or a computer science person or a software engineer to get the kind of AI that we've used up and running at your facility. But, this is changing rapidly. Tools like LM Studio that allow you to download and run AI locally on your own computer using that sort of more familiar chatbot interface, they're only going to get better. So they're not good enough right now on the exact date that I'm recording this talk, but in a couple years we may have secure, locally available AI tools that are reasonably easy for a non-technical person to use that will allow us to extract meaning from all of this data. So I think there's a lot of potential here, and it's something that we're pretty excited about.